Methane in general is 25 times more potent than carbon dioxide as a greenhouse gas, which is why it's very important for us to be able to capture this methane before it goes into the atmosphere and then recapture some of the energy that was stored in it to use before that it's released as byproducts. The energy density of methane is 38.4 joules per liter at standard temperature and pressure, which is not very much. However, that's why we compress the methane into compressed natural gas. We can use over 3,600 pounds of pressure so that we can increase the energy density by 10 or 20-fold. An anaerobic digester works by processing biological waste in the absence of air. So anaerobic means without air, so this entire apparatus has to be airtight in order for this to achieve maximum methane production. First, you put the agricultural waste mixed with water in the intake valve, where it settles into the container. Then the bacteria in the waste produce methane, which is then captured through this tube and into the collection system, which can be as simple as a balloon or as complex as a giant tank filled with compressed natural gas, which is the methane that is produced, and then from the container it goes into a valve that you can use to get the methane, and which you can then combust or produce electricity or use for many other different purposes. The sludge, the waste that you put in, is also, after the methane is extracted, is a very good fertilizer and lasts much, much longer than just the waste by itself or any other type of nitrogenous fertilizer. So you can take this waste product and use it to produce more crops. For my energy calculations, I assumed that we used a bigger outdoor trash can instead of the smaller version that I had built. The trash can has a capacity of 189 liters, which would multiply by 1 mole per 22.4 liters of gas at standard temperature and pressure. And when combusted, 1 mole of methane produces 861 joules per mole of gas, which equals 7,264 joules from combusting the methane that was in our larger trash can. To convert this unit of joules to something that makes a little more sense to the average consumer, I will calculate how long that 7,264 joules could run a standard 60-watt light bulb. So we start with 7,264 joules, and a standard light bulb is 60 watts, which is 1 second per joule, because a watt is 1 joule per second. And then we want it in terms of minutes, so we multiply by 1 minute per 60 seconds, which equals 2 minutes of running an average 60-watt light bulb. Another thing I could do with this methane that I produced in my anaerobic digester is make tea. So we're going to start with 7,264 joules again, and 1 joule is the energy it takes to raise a gram of water by 1 degree Celsius, so 1 degree Celsius per joule. And then I use a cup of water to make my tea, and a cup of water weighs 273 grams, so 1 cup per 273 grams. And I want to know how much I can raise my cup of water by. So if we multiply this out, we get 26.6 degrees Celsius, and that's enough to make my tea piping hot. In the US, there are a lot of different sources of methane that we can capture and then reuse to create energy. For example, landfills produce a lot of methane, and there are currently many companies working on systems to capture this and then burn it to produce electricity. Agricultural waste, like I used in my methane digester, also produces a lot of methane, which can again be captured and used to heat homes or power other things on the farm. Coal beds also produce a lot of methane, which we can try to reduce by mining less coal, but we can also capture and then use to power other instruments on the coal mining facility. The uses of methane include heating homes. A lot of our homes in Minnesota are heated using natural gas in the winter instead of just electricity. Methane can also be burned to produce electricity that we can use in our homes again. And also in Minnesota, a lot of garbage trucks run on natural gas. For example, Republic Services has 23 garbage trucks that use natural gas instead of gasoline, and they run 80% cleaner, so 80% less carbon emissions, and they're also much quieter than traditional trucks that run on gasoline.